In the mathematical model, here we have to apply KVL. We apply KVL, the current through this, let us assume that it is I of t. Therefore, the potential drop across this resistor is R I of t. The potential drop across this inductor is L di by dt. The potential drop across this capacitor is equal to 1 by C integral of I of t dt from minus infinity to t. So these are the potential drops. What is KVL? Algebraic sum of potential drop and EMF equal to 0. The applied voltage is VI of t. Therefore, the algebraic sum of, that is VI of t, applied voltage or EMF, and potential drop are the sum of EMF and potential drops in the circuits are equal to 0. Therefore, Y minus, if we travel along the current direction, there will be a fall in potential. If we travel along the current direction, there will be a fall in potential. If you see, this is the battery, say 5 volt. You are connecting a resistor across this. You know that what is the potential here? 0 volt. 0 volt. What is the potential here? 5 volt. So if we travel in this direction, there will be a fall in potential. That's why minus. So if we travel from A to B, there will be a fall in potential. That's why minus R I of t. If you understand the direction, then only you can put the correct sign. Minus R I of t. Again, we are traveling along the current direction. That's why again minus L di by dt. Again, there is a, we are traveling along the current direction. That's why there is a fall in potential. Therefore, minus 1 by C integral of I of t dt. That's all. Now, equal to 0. Algebraic sum of potential drop and EMF equal to 0. So now, this is an integral differential equation. Integral differential, because it involves both integration and differentiation. If you once take Laplace transform, what you will get is Vi of S equal to, if you bring all this to the right hand side and take Laplace transform, you will get Ri of S, assuming 0 initial condition. While taking Laplace transform, let us assume that always in control system, we'll assume that 0 initial conditions plus L S I of S, because for differentiation S, plus 1 by C S I of S, 1 by C S I of S. We are ignoring all initial conditions. If you assume that we are interested in I of t, if we assume that we are interested in I of t, means I of t is the output. We are interested in current through the circuit. Therefore, input is what? The applied voltage Vi of S. Therefore, if you find the, if you bring the I of S separately, so outside, you will get I of S R plus Ls plus 1 by Cs you will get. Or we can write, already I told you that I of S is the output. Therefore, we can write I of S upon Vi of S equal to 1 by R plus Ls plus 1 by Cs. Or if you take 1 by Cs outside, you will get Cs upon RCS plus LCS square plus 1. So if you put it in convenient form, CS upon LCS square plus RCS plus 1. That is I of S upon Vi of S. This form is called, this is also mathematical model. Earlier I said this is the mathematical model. Earlier I said this is the mathematical model. So this is in time domain. This is in frequency domain. There are many advantages writing the system in different frequency domain. One thing is, already I told you that if you inverse time, you will get frequency domain. So because omega is inversely proportional to time, that's why whatever happens at infinite time can be easily found earlier. Whatever happening at infinite time can be found earlier. That is the advantage, one of the major advantage of the frequency domain. There are many advantages that we will see later. But anyhow, this is also a mathematical model. This is also this is also a mathematical model. It is called transfer function. This is called transfer function. What is the definition for transfer function? Transfer function means it is Laplace transform of output upon Laplace transform of input. You see that what we got here? We assumed that I of t is the output. What is the Laplace transform of output? I of s. So this is in the numerator. Denominator, what is that? Laplace transform of input. What is we are giving in the circuit? The input to the circuit is voltage V I of t. That is Laplace transform of V I of t is V I of s. Therefore, the Laplace transform of output upon Laplace transform of input is called transfer function of the system. Transfer function also the mathematical model, but in frequency domain. Or we can say that it is in S domain, or we can say that it is in Laplace domain. It is in Laplace domain, or we can say that it is in frequency domain, or it is in transfer function form. It is in transfer function form. So, what is the definition for transfer function? Transfer function of a system is defined as ratio of Laplace transform of the output to the Laplace transform of the input with zero initial conditions. That is more important. With zero initial conditions. We cannot find transfer function unless it has zero initial conditions. If it has initial conditions, we cannot find transfer function. So, if transfer function is given means we can assume that it is assumed that the initial conditions are zero. Initial conditions are zero. We can immediately understand that the initial conditions are zero. So already this we have seen. Suppose instead of I of t as output, I can assume that the voltage across the capacitor as output. I can assume anything as output. Voltage across the capacitor as output, I want to assume. In that case, what we have to do is, we have to find in terms of, what is the definition for Laplace transform? Laplace transform, what is the definition for transfer function? Definition for transfer function is Laplace transform of output. Since we are assuming that voltage across the capacitor is assumed as output upon V I of s. If we found this, then it is also transfer function. But in this case, what is the output? Voltage across the capacitor is output. Therefore, already we found in terms of I of s. What is the equation? It is we found I of s. Now let us substitute the value of I of s from this equation. We know that Vc of t, voltage across the capacitor, equal to 1 by c integral of I of t dt. Integral of minus infinity to t I of t dt. So if we take Laplace transform of this part, what you will get? Vc of s. We can put V naught of s also. V naught means output. O for output. So we can say either Vc or V naught. Here we are considering it as output. That's why V naught of s equal to 1 by Cs I of s. Substitute in place of I of s. You substitute this. What you will get here is instead of I of s, we can substitute Cs Vc of s or V naught of s. So now we can find V naught of s by we can find V naught of s upon V I of s equal to Cs square upon L. We are taking L outside, S square plus R by L, S plus 1 by LC. Why I took L outside? This will be written later. It will be written C by L S square upon S square plus R by L S plus 1 by LC. This form is called pole zero form. I'll explain later. You cannot understand what is pole zero form. Here, what way we wrote another equation I wrote here. I wrote CS upon LCS square plus RCS plus 1. Here, finally, instead of the constant is 1. The constant is 1. All other has coefficients mean that form is called time constant. That form is called time constant form. Here, in this form, the coefficient of S square is unity. The coefficient of S square is unity. The coefficient of S square is unity. If coefficient of S square is unity means this form is called pole zero form. Don't worry, we'll see later. We'll see later. Why it is called time constant form, why it is called pole zero form, that we will see later. So now the transfer function of given electrical system is, transfer function can be called as G of S. Transfer function can be called as G of S. Transfer function can be called as G of S. The output of the system is assumed as V naught of S, that is voltage across the capacitor. What is VI of S? The input voltage applied to the circuit. What is the definition for transfer function? Laplace transform of output upon Laplace transform of input. That we got. That's why this is the transfer function of given circuit. In other words, the mathematical model of the system in Laplace domain, or mathematical model in frequency domain, or we can call it as mathematical model in transfer function form. All are same. We have seen how to obtain mathematical model of electrical system. Now, let us see mathematical model of a mechanical system. This is called the mathematical model of translational system. Mathematical model of a translational mechanical system. Mathematical model of translational mechanical system. In all electrical system, it has the quality of, it has the characteristics of resistance, inductance, and capacitance. A transmission line. The transmission line means where we are getting power, electrical power. It is generated in NLC. Suppose we have only one power station, NLC means definitely it must be from NLC. But here we do not know, because all power generating stations are connected as a grid. That's why we cannot claim that this power is generated from NLC. We cannot. But anyhow, let us assume that the power is coming from NLC only. So it is generated there, and its voltage is raised to 2200 volt. Then it is transmitted from Neyveli to Pondicherry. Here we are getting the power. If you see that it is only wire, you are thinking that it is wire. It has the property of inductance. It has the property of capacitance also. What is the definition for a capacitor? If the conducting medium separated by two conducting mediums are separated by a dielectric medium, two conducting surfaces are two conducting mediums or two conducting surfaces are separated by a dielectric medium, then it is called a capacitor. Two wires are coming, three wires are coming, R, Y, B, three phase. Three wires are different, each has a different voltage with respect to ground. Two conducting surfaces are separated by a dielectric air medium. So it is also a capacitor. Capacitor function also there. Inductor means what? If a coil is in a magnetic field, if a current carrying conductor, automatically it will be in a magnetic field because it induces a magnetic field. That's why it is in magnetic field. So a conducting surface in a magnetic field, then it is called inductance. We can think inductance like that. So there are three wires, R, Y, B. One more is there. That is called neutral. Let us ignore. Three wires are there, R, Y, B. Each has different potential. Each generate a magnetic field. The magnetic field generated by that wire is in that magnetic field, self-magnetic field. Adjacent wire also produce magnetic field. In that, this R wire is in the magnetic field produced by B and Y. That's why it has inductance effect also. Therefore, any electrical system, if we consider, it has the property of resistance, because wire has resistance, you know. It has the resistance property, it has inductance property, it has capacitance property. That's why any electrical system is made up of resistor, inductor, and capacitor. In the same way, any mechanical system has three properties. One is mass, it has the mass. All mechanical system has a mass. Mass means because of gravity, it converted into weight. Mass becomes weight under gravity. So mass. Another property is spring. It is like inductor, or you can say it is like capacitor. Sometimes it looks like inductor, sometimes it looks like capacitor. We'll see later. So a spring effect is there. Suppose a rod is there. If you pull that rod, what will happen to that rod? It will expand, no? If you release, what will happen? It will regain the original shape. So it has the spring property. It has the spring property. It has the dashpot property. In computer center, if you say there is a door closer will be there. Door closer will be there. If you open that, நமக்கு அந்த பழக்கமே கிடையாது. டோர்ல சத்தம் வரும், நம்ம பார்த்து க்ளோஸ் பண்ணணும்ன்றது. One rod is there. You are one end is fixed, other end you are pulling down and leave it. What will happen? It has the spring effect as well as it goes slowly to that point, or it oscillates and finally settles. Oscillates and finally settles. So that effect is called dashpot effect and the spring effect. So any mechanical system, if you model it, it has the property of mass, it has the property of spring, it has the property of dashpot. Does it mean that the mass is attached with a spring, attached with the dashpot? Mass itself has the property. Already for that, I told you that if you take a rod, if you pull that, it has the spring effect. If you leave it, it regains to original position. So all mechanical mass has the three properties. One is mass, the second one is spring effect, the third one is dashpot effect. So similar to electrical system, if you obtain a mathematical model of electrical system, it has resistance, inductance, and capacitance. Like that, if you obtain a mathematical model of a mechanical system, it has three properties. One is mass, spring, and dashpot. First, let us consider the spring. So spring means how we will draw like inductor. So this is spring. One end is fixed, other end is free. If you apply a force here, what will happen? It will elongate. It will elongate because spring. If you make the force equal to 0, if you make the force equal to 0, then again it will regain to original position. So it means what? If you apply some force, Newton's third law. If you apply a force, there will be equal and opposite reaction force. So spring will generate another force. Because of that, the spring is here. If you apply some force, what will happen? If you apply a force, it will elongate. So it will develop an equal and opposite force. That force is depends upon the displacement. Here, the displacement is x. Displacement, if you displacement is more reaction force will be there. The spring constant is k. The spring constant is k. Therefore, the reaction force by the spring effect is Fk equal to Kx. The force developed by the spring, the opposite force developed by the spring is Kx. If it doesn't generate that force, the spring will move. If it doesn't generate that force, opposite force, the spring will move. I understand that. So that the reaction force is Kx. Applied force is F. It must be equal. Otherwise, it will be moving. Otherwise, it will be moving. These two are equal. Therefore, we can obtain a mathematical model F equal to Kx. As far as spring is concerned, we can write the mathematical model. If spring alone is there, let us assume that it doesn't have any mass, it doesn't have any dashpot effect, then the mathematical model of the spring, let us assume that spring doesn't have any mass, zero mass. No ideal spring is there in the world. It has some mass, but let us assume that it has some zero mass. In that case, the mathematical model is F equal to Kx. the stiffness constant, where K is the constant of the spring, its unit is newtons per meter. The displacement is in meter. Therefore, if you multiply these two, you will get Newton, that is in the left-hand side. If you write any equation, the units must be correct. Whatever the left-hand side units must be in the right-hand side. That way you can check whether the equation is correct. In lower class, you must have studied both sides, whether the equation is correct or not, how we can check it, whether the unit is on both sides correct or not. So here, both sides we have the Newton unit. Therefore, the unit of K is stiffness constant, Newton per meter. One end is fixed. The previous case, what we have seen is one end is fixed. Both ends are free means, what will happen? In this end, I am applying a force of F. This end displaces a distance of x1, and this end is fixed means zero displacement. Therefore, the force developed in the spring is kx1, we can simply write. But this end is moving. This end also moving. A distance of x2 means total deflection depends upon the total elongation. The total elongation is x1 minus x2. Am I correct or not? X1 minus x2. Therefore, the reaction force is x1 minus x2. K multiplied by x1 minus x2. The reaction force developed in the spring, if both ends are free, is kx1 minus kx2, or K multiplied by x1 minus x2. X1 and x2 are in both same direction. That's why elongation is reduced. Both are in the opposite direction. What is the reaction force? K multiplied by x1 plus x2. Because this end is moving this side, this end is moving to the right hand side. That's why total displacement is x1 plus x2. Therefore, K multiplied by x1 plus x2. Both are in the same direction. Therefore, deflection is reduced. The deflection is proportional to x1 minus x2. That is, deflection is equal to x1 minus x2. Therefore, reaction force is kx1 minus x2. The applied force is F. Therefore, the mathematical model is F equal to K multiplied by x1 minus x2. The second case, dashpot. Dashpot is the basic property of mechanical structure. Basic property of mechanical structure. But this can be understood by this dashpot. Dashpot means, suppose I don't want to, if you leave something, if I leave, it vibrates and then settles, means I don't want to vibrate this. It should go slowly and reach like our door closure. In that case, what they will do, they will put a piston here. They will put a piston here. They will take a piston. This is the piston. Small gap will be there. Here, small gap is there. You can notice that small gap is there. If this side is filled with the liquid, means this cannot move very fast, because the liquid has to displace from this side. Because of that, it will be very slow and it will not oscillate. That behavior is called the dashpot. So this dashpot property also there in the mechanical structure. To write the mathematical model, this will exist only if it is moving. If one end is moving, then only the dashpot property will exist. The door will slowly close. Once it is closed, there is no displacement. Once it is closed, there is no effect, dashpot effect. Therefore, when velocity is there, then only that effect will be there. If you apply some force, the dashpot effect, the force due to dashpot is proportional to the velocity, the displacement, that is dx by dt. It is proportional to applied force. It is proportional to applied force. That reaction force is equal to, proportional to dx by dt, proportional to dx by dt, that is equal to v dx by dt, v dx by dt. So this damper effect or dashpot effect is v dx by dt is proportional to velocity of the mass, If one end is fixed, you are applying a force at one end, other end is fixed, the force applied is F, the displacement is X, the velocity of displacement is dx by dt. In that case, the, the reaction force FB equal to V dx by dt, where B is the dashpot constant. So the mathematical model is F equal to V dx by dt. The dashpot will be drawn like this. Dashpot will be drawn like this, like capacitor. If you draw capacitor in electrical system, how you will draw? Like this. In addition to that, you have to put like this. If you put like this, this is called a dashpot. Sometimes the dashpot also will be written like capacitor. Some books, both are dashpots. How spring is drawn? Spring will be drawn like this. This is not a separate spring. The mass has the property of spring. The mass has the property of dashpot. But this you might have noticed in a DC analog meter, there will be a coil. While drawing the coil in circuit, you will draw this inductance in series with the resistor you will put. Have you noticed that? There is no resistor separately there. Inside, if you see, one coil will be there. The coil has both the inductance property as well as resistance property. While drawing, while putting the circuit, we are separately mentioning the inductance and resistance. But if you see inside, it will be a single coil only. While representing a motor, DC motor, how it is represented, it has inductance in series with resistance. But if you see the coil, resistance you cannot see separately. The coil has the resistance. That way, in the mechanical system, if you put like this, this mechanical system has mass, it has a spring, it has dashpot. It doesn't mean that they are separate. The mass has all these properties. But while drawing, while putting in circuit, illustration, through illustration, if you demonstrate the mass, we put separately, like circuit, that's all. So the applied force is F, the displacement is X, the velocity is derivative of displacement, that is dx by dt, the reaction force is B dx by dt. Therefore, the mathematical model of the dashpot system is F equal to P dx by dt. Here it has no mass, no spring effect, only dashpot effect. The third case is if a dashpot, both ends are free. One end is moving at has a displacement of x1. Another end has a displacement of x2. So here, what is the velocity of this end? Dx1 by dt. Here, what is the velocity of this end? Dx2 by dt. Therefore, the FB equal to the reaction force, because of the applied force F, the reaction by Newton's third law, the reaction force is FB equal to V dx1 by dt minus same direction. That's why minus V dx2 by dt. Dx2 by dt. So if both ends are free, then the mathematical model is F equal to B dx1 by dt minus dx2 by dt. That's all. It has no mass, it has no spring effect. Suppose the mass has only mass effect, no spring effect, no dashpot effect. Here, if a mass is there, if you apply any force, there will be a inertia. Because of that inertia means mass. Because of that inertia, it generates some opposite force. which is equal to second derivative of displacement, first derivative of velocity or acceleration. The reaction force is equal to acceleration or second derivative of displacement or first derivative of velocity. First derivative of velocity. We can say that reaction force is Fm is proportional to d square x by dt square. Second derivative of displacement, or it is proportional to dv by dt velocity, or simply that is proportional to acceleration. That is proportional to acceleration. Acceleration, how to understand acceleration? If a mass has whether acceleration or not, how to understand? If acceleration is not zero, the mass will move in future. You consider a simple pendulum. If it is vertical, it is moving like this. When it has the maximum velocity, when it is vertical. The string is vertical, it has maximum velocity. It goes. At the end, its velocity becomes zero. Velocity becomes zero. Velocity becomes zero, now it should rest, Why it is coming back again? Because its acceleration is not equal to zero. Its acceleration is not equal to zero. Why acceleration is maximum? What is acceleration? Rate of change of velocity. Earlier it goes this direction. After that it has to come this direction. Direction is changed. That's why velocity is, if we differentiate maximum, direction is changed. That's why velocity, the rate of change of velocity is maximum. Rate of change of velocity is maximum. That's why its acceleration is there, but no velocity. Acceleration is there, but no velocity. That's why it is coming back. That's why it is coming back. So from that, we can understand that if acceleration also zero, then only the mass will become rest. That's why we have to remove the acceleration. We have to remove the acceleration. What we are doing while applying brake on the vehicle, we are removing that force proportional to that acceleration. If mass increases, that energy stored in that mass increases. For example, a cycle is moving at a speed of 4 kilometers per hour or 8 kilometers per hour. Those who are good stamina can pull the cycle and stop. Let us assume that cycle is moving at 4 kilometers per hour. You can pull and stop the cycle. The same velocity bus is moving. Are you able to pull and stop? No. So because you cannot remove the entire energy in the mass. Therefore, the mass has some energy. That energy, if you want to remove, you have to apply brake. That energy is converted into heat. That is different. We don't want to see all those things. So the energy is proportional to mass and acceleration. The energy is proportional to mass and acceleration. The force is equal to mass and acceleration. That mass is constant. So Fm, the reaction force, is equal to mass multiplied by acceleration, or m d square x by dt square. M d square x by dt square. So these two must be equal. These two forces must be equal. That's why it must be equal to F. Therefore, the mass, which has only mass, no spring effect, no dashpot effect, means the mathematical model is F equal to m d square x by dt square. D square x by dt square. If it has all the three properties, then the mathematical model is F equal to m d square x by dt square plus kx plus b dx by dt. If it has all the three properties, then this is the mathematical model. It is identical to electrical system. It is identical to electrical system. It is identical to electrical system. Before obtaining the mathematical model, we have to draw the free body diagram. Free body diagram. We know that if you apply some force, there will be a reaction force. Third law says One is called, because of the mass has spring effect, that's why Fk. It has Fk. It has a dashpot effect, that's why the reaction force is Fb. It has mass, that's why it has Fm. All these three reaction forces, always it will be opposite to the applied force. Always to the applied, opposite to the applied force. The applied force is F of t. Applied force is F of t. And the reaction forces are Fk plus Fb, Fb plus Fm. They are in the opposite direction. That's why I'm writing on the right hand side. Or like KVL, we can say that F of t minus F of k minus F of k minus F of b minus F of m equal to 0. That way also we can write like KVL. So what is free body diagram? If the body is not fixed to any other mass, then it is called free body. If you apply some force, it will move. But if it has a reaction forces and equal to the applied force, then it will be stand still. Now this is a free body. Now this is the free body. In that we are applying a force of F of t. The reaction forces are F of k, F of b, and F of m. That's why this free body remains there. The free body remains there. That's why this diagram is called free body. Free body diagram means we have to take the mass. What are the forces acting on it? If you mark, then it is called free body diagram. Here, this is the mass. This is the mass that we have taken. This is the mass that we have taken, m. It has the property of spring. It has the property of dashpot. If you apply some force, there will be a reaction for m. The force is equal to m d square x by dt square. Because of spring effect, it has k x. Because of dashpot, it has b dx by dt. So these are all marked in the free body diagram. All forces are marked in the free body diagram. So to obtain mathematical model, we have to draw the free body diagram. The forces acting on it has to be marked on that. Then we can write the mathematical model. What is the mathematical model? F of t equal to m d square x by dt square plus b dx by dt plus kx. This is the mathematical model in time domain. The frequency domain we will see in the next class.